what I'm going to do today is I'm going to illustrate the fact that, as we all know in this audience, that data, mathematics, AI can be a powerful tool for decision making, but there are also human elements that need to be very carefully taken into account. And I'm going to do it through a case study because I find that much more accessible. This was a particular case study which we used. We worked with the National Archive to help preserve digital objects, and in the end it became a tool which they were able to go to government and get substantial uplift in funding. So we'd count that probably as a good success for decision support. So let's see how this works. One of those? Excellent. Yeah, so basically the idea is that we're going to just have a little sort of what is the problem so that we understand that better, and then how do we go through the steps of the project, including the data elements, including the human elements, and then what do we get out at the end. Lovely. Okay, so archives. I don't know if any of you have ever done any research into your organisation or your family tree or anything like that, but they rather than libraries getting lots of copies of things, they have the original object. There may only be one of them. They may be hard to access and that kind of thing. So a lot of us have been to churches to look up records and so on. So they can be all sorts of different things. And increasingly these things are born digital. They are always been digital. They've never been paper. Other things have been digitized. So they were paper or something like that, or a 3D object which has been scanned, but they are now held digitally. And the challenges that are faced in preserving such things are different from the physical objects. So government archives in particular are important because they have a regulatory framework. So the National Archive has to keep the records of certain government departments forever. And doing that in a digital setting is quite challenging because digital carriers are not as reliable as paper. So there are lots of different kinds of archives, and what they might keep is different, and the control over the ingestion process can be very different. So the National Archives, because government departments have to deposit, are able to then put regulations and standards on what they will ingest. You have to give us a checksum, you have to give us this format, it has to be renderable, blah, 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 and the provenance and so on. Whereas a smaller archive, the one on the University of Warwick, has to do with trades unions. They might just get a box. They may have no idea where it came from. It came out of somebody's loft. There might be some digital stuff in there. There might be some paper stuff in there, some stuff they want to digitize. So there's quite a variety of different archives, and they were all involved in the development of this. And the National Archive in particular is kind of an industry leader. They set the standards, they help the smaller archives with kind of resources. They're better resourced than most, although resourcing for archives is always a challenge. And there tends to be this idea that you need to do a particular project on something. So you get project funding, but this is the ongoing project, the ongoing funding for the sustainability really often isn't there. So unsurprisingly, the act of preserving digital records is called digital preservation. And some of the challenges are including these sorts of things. So we've all had software that has become obsolete in our lifetime because software changes so much. You know, when I was doing my degree, 2005, 2008, we had to submit paper reports with a floppy disk. I mean, who has a floppy disk anymore, right? And that doesn't seem to me all that long ago. It's since 2000. So you can store your photographs, but Google has said, well, there's a limit now to how many photographs you can have, what size of storage you can have. If you upload them to Facebook, they will be compressed, and so when you download them, they won't be the original anymore. So there's all these sorts of things, and then if you have to store them on a digital medium, it has a finite life. The best is about 10 years. So you have to make a copy, and then there's the risk of copying errors. And you don't kind of get that kind of thing in paper. If you keep the temperature right and you keep the humidity right, then it's going to be okay. So a whole different set of risks. And what the sector hadn't had the opportunity to do was to really think about how those risks are interconnected, where the evidence might be for them, how to quantify them, and so on. So I've said this about the funding is not sustainable, and it's really hard to advocate for funding when essentially what you're doing is sending messages into the future. That's what storage really is. You want it to be accessible. You're not going to benefit. Future generations are going to benefit. And I think there are similar kind of cognitive problems with sort of climate risk and things like that. If climate is going to significantly change, it's probably going to affect the next generation or the one after that more than it is us, but we're going to bear the cost. And so when you do get your project funding, or if you have opportunity to apply for project funding, what do you apply for? Because you have no way of balancing, well, this is more strategic than that, because you know things help, but not particularly by how much. So one particular methodology that we contributed was the integrating decision support system. The idea with this is when you've got a big system, you can break it up into its expert domains, and you can ask the expert panels for contributions towards a bigger whole. This is when you can't make a big system because it will take forever to run, or you change one parameter and you're really struggling with computational power or something like that. So this is the sort of idea which the National Archive was very taken by. And the advantages of these kind of things is that they are very white box. So a lot of the graphical models will fit into this paradigm. You can say we're going to do something, and if policymaker says, well, that seems a little bit, why are you doing A instead of B, or this collection of things instead of that collection of things, you can say, well, actually, our measure of success, our utility is this, it has these different attributes, we've weighted them in this way, we've combined them in this way. So completely transparent. If they want to upweight health and downweight finance, then they can do that and adjust it likewise. And similarly, if they're still not happy, you can say, well, actually, we've got an expert panel, the Met Office has told us about future climate. You can ask them why they gave the estimates that they did, the probability distributions they did under this scenario. So again, you can go back to all your expert panels and you can make it completely white box. And this is a very important property when you're dealing with government or people who are going to be accountable to government. So if you get sent to the scrutiny committee, or if you get audited in some way, to be able to say, well, this is what we knew at the time, these are the experts we consulted, these were the estimates they gave us, you've got a very defensible decision there, even if things turned out differently afterwards. So the project stages: soft elicitation, then the model building, then the quantification of the model, then the evaluation and feedback, then the software engineering, and then we were able to launch and adopt. So what is soft elicitation? Soft elicitation sort of is when, as the analyst, you get into the head of the problem, the head of the problem owners. You find out what are their values, what are their pressures, what are the things that they need to know. And as a lot of us will know, that sometimes they don't really know what they want, but it's actually in those discussions that the question is refined to something which can be really clearly specified. We need to know this. And that is a process in itself, and it's a very human process, and it's not something that we teach undergraduates, but it is something we probably should teach undergraduates. So it's really important. Who do they rely on? What are their values? Who do they consider to be the experts in the fields in which they're interested? Given the factors which are part of the system that you're modelling, how do they interact? Are they independent? Are they dependent on each other in particular ways? How do we capture that as well? What about the uncertainties? Where are they? What kind of uncertainties? Are we thinking about actor uncertainty? Are we thinking about stochastic uncertainty, model uncertainty, parameter uncertainty? What kind of uncertainties are? What effect do they have on the outcomes that we're interested in? And how might we go about modelling this? Okay, so what data is available and so on. So this is a process, and it kind of feels like this is the thing you have to do to get to the beginning of the problem, if you're a mathematician in some senses. But it's a really important stage, because if you don't specify the problem correctly, you're not going to answer the right question. So in this particular case, as I said, we're sending messages to the future. They need to be faithfully transmitted to retain their meaning and be useful for generations to come. But the world is not static, and the threats are constantly changing. And and the archive's resource and ability to deal with the threats change as well. So they needed a new framework to describe the system that they have. What is the risk to digital resources? This was a really interesting process, the soft solicitation, 3 or 4 decision workshops, lots of different archives, discussing the kind of threats that there could be, which ones are significant, which ones can be discounted. Really interesting discussions about at what granularity the model ought to sit. You know, did you want to model every different brand of magnetic tape, or did you want to have a distribution over magnetic tape in general, for example? And again, if you've worked with as an analyst with people in an expert domain, you'll know they want to model every little detail, because this is the world in which they inhabit. But trying to persuade them or trying to come to some consensus about an appropriate level, because at that level an input here is going to have an effect on our utility, our output that we're interested in, is really a really interesting and sometimes delicate negotiation. So what we want is to be able to compare and prioritise very different types of threats in the digital space, and operates even where the data is imperfect or limited. So this is the map that was the eventual outcome, the sort of the consensus map of how things are. So the two attributes of the utility are renderability and intellectual control. So can you see or render this object sufficiently for the use for which you need it? Does it need to preserve all of the formatting in the original, say, document, or is reading the text sufficient? And intellectual control, can you guarantee that this document is the document that you ingested at the beginning of the process? It hasn't been tampered with any way, it hasn't been corrupted or so on. But there are lots of interactions there. You have the digital object itself, and do you have a checksum for it? What about the file format? What about the metadata, and so on and so forth? So there's lots of things about this to discuss. And then, of course, the notes all have to be absolutely defined. What do we mean when something has rendered sufficiently? Can we put a number on it? Can we say this has rendered sufficiently, yes or no? This has intellectual control, yes or no, or to some degree. So we need to have clear definitions before we can actually apply a measurement to that. So we need to know something has happened. It's called the clarity test. And then we say, well, what is the data? Well, there are some surveys that the National Archive had done. There are some reporting standards that they have across the industry, and those were all valuable parts of the data, but not every piece of data that we might want was available. So we then employed structured expert judgment, where you get panels of experts to give you probability distributions for questions of interest, so that you can then control the quality of the data you're getting out of the experts in such a way that you can use it with confidence. So we use the IDEA protocol, and essentially what you do with this is you gather the information ahead of time. All the experts get a copy of the information pack. Then you ask them the questions that will give you the data that you want. You mix in some calibration questions where you actually know the answers. Then you ask all of your experts to give a private estimate, so they're not being influenced by anybody else. Then you bring them together for a facilitated discussion, facilitated so that you can actually quieten down the person who wants to give all the answers and bring in the person who's a bit quiet, and those kind of things. And the experts' first round data is anonymised and sort of presented as anonymised to the group, and they can say, well, under what circumstances could this question have a value as low as this, as high as this, and you talk about the extremes, you talk about the central values. And that means that everybody has the same access to the same information. If you had a piece of information that I wasn't aware of, or I was thinking about the question in a different way, then that can be ironed out. And then you ask them to go and give a private second round of estimates. You use the calibration questions for weighting. Some experts are really good at capturing the correct answer, but maybe they do that by having very wide uncertainty bands. Let me see. So they look like this, and you can see that this expert, for example, is very certain about where the value should be. It's somewhere around 800. We turned all the questions into natural frequencies, because for experts that are not mathematicians, that can be a much easier way to think about things. This expert has probably captured the correct answer by just putting could be anything, you know. So this expert is very informative if they're correct. This expert is likely to be very accurate because they're always going to capture the correct answer, but not very informative. And there's a balance between informativeness and accuracy, which contributes to the weight each expert is given. So then you can do a weighted sum or some other aggregation. And this is what the tool eventually looked like. It's on the web, you can go play with it. So each archive starts with answering a set of questions, and they are tied very much to the kind of questions they have to report anyway. So they should have that data to hand, and that customizes the network to their particular situation. They are shown the structure. You can click on the nodes and get the definitions. You can convince yourself that this is an accurate representation of the system or not. And if you think not, then you're not going to use it. How things are defined exactly. So again, very transparent, so you can actually justify things. And what do you get when you get out? So you remember the renderability and intellectual control. You get a score, and this is your model in the middle. One of the things that we realised during user testing was the score doesn't mean a whole lot, because you don't really understand where you sit in the grand scheme of things just by having the score. So sort of a National Archive-like well-funded National Archive is given as a comparison, and also bunging everything on the cloud is given as a comparison. So then you're in a better position to see where you sit as your particular archive compared to those two things. And then what you can do then is say, well, what if we invested more in digital skills? What if we invested more in replication and refreshment? What if we invested more? And you can actually put those scenarios in and see how the different risks change. And it was on that basis that the National Archive got significant uplift in funding. The Digital Preservation Awards made some very complimentary comments about the project as well, about how it really helped in digital preservation in a way that hadn't come through yet. And COVID was actually a huge opportunity for us in the sense that we were planning to spend money on physical meetings and accommodations, and then we couldn't because we couldn't bring people together legally. What we were able to do then is to do our user testing online and then capture the USA, Brazil, Australia, do it at different times to bring those people on board. So we had a much bigger, a broader international validation, and we had the money left over, and we employed software engineers with that to actually make the code replicable and sustainable for the future, which was a great move because then that meant it was able to be made into a proper tool. And the Decision Analysis Society and Society of Decision Professionals decided it was their winner for 2022 of the Practice Award, which was very nice for us as well. But the thing I liked most about it is, yes, the National Archive got a significant uplift in funding, but the head of Digital Archive said it has changed the way we think about archiving. We now think in terms of risk. So this whole project had made a culture change within the archive itself, and they're thinking in terms of risk, which is great, I think. So just to conclude then, mathematics, AI, data science, and all these are brilliant at decision making. We have to include the digital, the human element as well as the digital.